All right, so next up, what I'm going to do is start to look at this as a bit more of a form-finding exercise. So we're basically going to look at this as like a layered system of inversions, right? So let's to start start this off. What I want to do is, instead of an extrusion, what I'm going to do is actually move the surface upward, and then I'm going to modify them differently, and then I can start to connect them together. Okay, so basically, instead of extrude, I can use move. So let's go to transform and Euclidean, and I'm going to use move instead. And move is going to require two very similar elements. It's going to need a base geometry, and then it's going to need a translation vector with direction and magnitude. So we're not using the, well, yeah, we'll use the unit z again. So I'll plug that in here. And then the geometry is going to be the, you could use the scaled geometry, or you can go all the way back to the original surfaces and you can move those upwards and scale them differently. In this case, I'm going to use the original surfaces. So that would be these here. So I'm going to clean it up a little bit though, and I'm going to create a param and name it. Original surface. I'll make this wireless. Plug that in. And that will have to be flattened. There you go.
How'd you do the param again?
That's weird. What's that?
How'd you do the wireless param?
Wireless, you just right click it here and wire display, hit it. You good? Okay. All right, so what I'm going to do here with this one, I basically move them all upwards. Oh, it looks like I have an error on the corner. I move them all upwards, and now I'm going to basically modify what that particular item is. And so in order to see it, I'm going to turn some of this old stuff off. So here's what I'm working with, and I want to change this one as well. I could either rotate them, or I could scale them, or I could rotate and scale them. Any number of things. Let's start off by first scaling it. And so I'm going to copy the scale, remap, domain, and everything back to these two sliders. And I'll pull it forward. So now the move geometry takes over for the scale geometry. And in fact, you might want to just go through and disconnect a lot of these first so you don't have looping issues. So let me disconnect some of these. All right, there we go. So the geometry I'll plug into scale. And I'm going to need to measure its center point. So I'll go to Surface, Analysis, and I'll plug that in here. And I'll get its center point there. And so the next step here is to do the remapping. So these are also dependent on the center point. But I could make a different one for this one as well if I chose to. And so that's what I'm going to do. I'm going to drop another point in, and I'm going to kind of put it over on this corner. And I'm going to slide this one over there. There we go. So let me kind of reset this up. Yeah. I'm going to need to get a boundary, closest point, and the area. But let me just kind of do that all fresh. So I'll go to param. I'll reference that point in. Then I'm going to do under vector and point, I'm going to use closest point. So the point goes into the cloud, and the centroid of all of these surfaces gets plugged into P, our points to search from. And now we have our new distance value. So this distance value is going to be our source, or our original V, and our source domain is obviously going to be measured with bounds again. So math, domain, bounds, there, there. And now you can see that this geometry gets scaled like so. You guys keeping up? No? I moved a little faster on that one. All right, so I'm going to clean this up here for a moment. And I'll pause the video, I'll clean this up, I'll get you guys all caught up before I move on to the next step. So are you starting to notice a bit of a theme here? Like when I'm doing these abstract exercises, I tend to sort of layer in lots of different iterations of the same idea, but in slightly different ways. And more particularly, now I'm starting to implement older ideas. Like now I'm automatically throwing in scales. I'm automatically throwing in moves. Stuff like that that you can use again and again and again. So what I'm going to do here real fast with you all is I'm going to take these newly sort of paired up groups. So this is the one that's above. This is the one that's below. And notice how they're sort of inversed, right? Yours might not be inverse depending on how you set it up, but mine is. That was the intent. So I need to, I'm going to loft them together basically. I'm going to create a loft that's going to blend these things together. So to do that, I have to, loft doesn't really work between two surfaces, so you have to find the edges of the surface and loft those together. So I'm going to do a deconstruct beer up on both of these. I'm going to take all 4 edges, because they're going to be broken down into groups of 4 edges for every panel. Then I'm going to loft them together. So I'll go to Surface, Analysis, and I'll just grab my deconstruct BREP, and I'll break down that set, copy paste, break down this set. And so ultimately, with both of these, I should be able to just loft these two on the edges. And to make it sort of more visible, I'm going to turn off that deconstruct BREP that I just generated. And I'll use freeform and ruled surface, I think I'll try. And so I'll plug my edges in from A and my edges in from B. And here you can see this rather dynamic sort of, prismatic function here. It's rather interesting, I think. So now if I wanted it to invert again, where the smaller tips are sort of the lower ones and the fatter tips are going to be the higher ones, I just need to remove the inversion factor that I put as an expression on both of these. So here under this scale, I can right click my expression and take that off. So I'll do that real fast. Let me take this off. Now you see they're back to mostly straight extrusions again, at the top end anyway. And then I'll go to this one and I can take that off as well. You don't have to take yours off, but I'm taking mine off just to show you. So now it's inverted. You have your thinner ones in the middle with sort of a thicker top, and then down here you see that these prisms down here in the corner are a little softer. Any questions about that right now? All right, so let me go back. I actually did like it a little better this way. I think it gave me a little bit more of, you could see the forms a little better. So I have one more modification that I'm going to do to this, and I'm just going to slip another one in. I'm going to put a rotator on one set, and my rotations are going to be sort of customized per, again, their proximity to the attractor point. And I'll pick one of the ones that I probably already have. So anyway, let me kind of work backwards from that. And this is the geometry. I'm going to rotate the top geometry, not the bottom geometry. And yeah, so let's do that. I'm going to slip it in to this area right here. So I'll go to Transform, Euclidean, and I'm going to rotate object in a plane. I guess I'll just use this one for now because it's in the XY. So the geometry I'm going to rotate is going to be this geometry, which is going to automatically slide me over there. The angle is something I'm going to set using my closest point feature. And then the rotation plane is going to happen basically on the centroid of every single one of these surfaces, these ones right here. So I'll go back to Surface and Analysis. I'll plug that in. And then I'll plug that into Plane. And they're going to look the same right now because they're rotating 90 degrees and these are squares. So now our task is setting the rotator, so the rotation angle. So let's do that. I'm going to, let's see, I'll use, yeah, let me use, I'm going to just borrow this previous remap right here. All the way back to the point. And I'll need this as well. Copy, paste, pull it out. So this one I'm going to build off of the scale. Okay, so the scale is going to take over for area. The point I'll leave the same. It can still be the same point. I'm okay with that. But my domain is going to change. So now I'm doing rotations. And these rotations are going to have to be numerical values that range from something that's kind of reasonable. So in this case, I'm going to do a -45 to a +45. So I'll make a slider so that I can change it a little bit. So I'll start off with a slider from -45 to +45. We'll put that there. Copy, paste. Put that there. Make it +45. So this is just my starting point. I'll play around with it later, but slide this a little further out. This is going to go here. So now this remapped value looks a little something like this, right? So they're all values from between -45 and +45. I just need to now make them radians. That's it. That's all I have to do is change it to radians and then plug it in. So I'm going to go to Math, Trig, Radians, take that whole list, plug it in, take that list and plug it into Rotate. Now you can see that it's really starting to rotate quite a bit. And then that geometry, actually, I want to invert this now that I'm looking at it. Well, we'll just plug it in and go from there. Anyway, so this geometry goes into deconstruct brep. And then you can turn all the old stuff off again. Now you can see their rotations. Oops. There. Okay, so it's an incredibly dynamic thing, this ruled surface here. All we really have to do now is just kind of change our rotational factors, and you can see the whole thing starts kind of having at it. It's a really intriguing thing to build these volumes that are super massive. So as sort of a departing thought for this particular exercise right now, I want you to think of this in terms of what its applicability can be on a grand scale, right? So this is kind of just layered closest point values with different geometrical modifiers, but every single one of these panels now, or every single one of these surfaces is completely unique. It's a completely unique size. It's a completely unique angle. It's basically, if you do this, and this is only for how many items? We have 100, so I mean, we only have 100 things here, right? But imagine that you can do this on a facade with a couple 100,000, and that's pretty powerful. Any questions? Besides, help me get caught up because you move too fast.
Where do you get the rotate from?
Rotate, it's under Transform Euclidean. I used rotate object in a plane. Yes?
Zoom in?
Yeah, I'll zoom. Okay. Hang on.